Okay, so this is linear regression, but now we're going to be doing a beta test with a beta interval. In the majority of texts, beta stands for the population slope, thus small b is the sample slope, or the slope calculated based on sample statistics. So in a hypothesis test with beta, we're testing the slope, and depending on what the slope comes out to be, or what we think the slope for the population is, that can apply things about the relationship. So it's a very similar test to when we were doing a row test about the correlation coefficient. It comes to the basic same conclusions. So we're testing beta equals 0, meaning the slope is 0. If the slope is 0, it's a straight line. It implies no correlation. We're testing the claim that maybe the slope is not equal to 0. Maybe there is some sort of correlation. If you're doing a critical value, you need a t 0.05 level of significance with degrees of freedom n-2. And we are using the data from the previous example. So your test statistic is plus or minus 2.776, and again that just comes off my t table. And you need to plot on the negative and plot on the positive. And then you would do your test statistic. Now B is the slope, SE is the standard error of estimate, sum of the x squareds over 1 over n, sum of the x's, and then square it. You should be able to already have all of these statistics based on our previous work. You should be getting a negative 3.92383. And as you can see, it falls into a rejection region, so we will reject. If you used your graphing calculator to find the p-value for a beta test, which will be the same for the row test, so it's fine, you should have got a p-value of 0.017088. The p-value depends on the critical value, and the critical value did not change. It's the same for the row test, and therefore it's the same p-value as for the row test. So you can just use the same p-value. Compare it to alpha. As you can see, it is smaller, so we will reject H0. When we reject H0, we're going to come to the conclusion that based on the evidence, the slope is significantly different from 0 at an alpha of 0.05, which implies a relationship of some sort. We don't know if we're getting a positive relationship or a negative relationship. We didn't test that claim. We only tested some sort of relationship either way. Now, for a corresponding beta interval, we're doing 90% confidence interval. If you've got a TI-84, I believe, they can do a beta interval. TI-89, titaniums, of course, can do a beta interval. And so they can do it all for you. If you're doing it by hand, you've got to find a test statistic, an error of estimate. You have to find a T confidence value, which will be different from your critical value up here. You can't reuse this. This is based on a two-tail area. You've got to look up a confidence critical value. So you do that, you use your SE, you use all this information. This error of estimate is slightly friendlier to calculate than the row interval, the correlation interval. So if I'm doing stuff by hand, I prefer a beta interval because he's just a little more friendly to calculate. We should come out with an error of estimate being 0.35365. Okay? And then, of course, we're going to use the slope from the sample data minus the error that you calculated, then the slope plus the error that you just calculated. I have the B from the previous written down there. I would plug that in. When you do, you should be coming out with an interval of negative 1.0045 less than beta, less than negative 0.297127. Okay, that should be your interval. Again, I'm not going through the tedious calculations with you because by now you are expected to be advanced level enough that you can manipulate these formulas for yourself. Based on the evidence, we got to do our conclusion. Based on the evidence, we're 90% confident that for every unit change in batting average, the percent strikeout is between, and you're talking about a slope here, so you can have negative values, and that's totally fine. It implies that there's some kind of negative correlation going on. But you just report your interval, and you've made your interpretation, and it sounds very fancy, and you're done. So that is linear regression, beta testing, and beta intervals, aka population slope test, hypothesis test, and a population slope confidence interval for linear regression.